So we were talking about algebra, and I know I hit all you with a lot of stuff. Last class was a heavy class. Today's class shouldn't be so heavy, right? But the reason why I hit all you with a lot of stuff is because I really wanted to show you guys how algebra is the same as number theory. So over here we had that we were adding two numbers, and in algebra we are doing the same thing. We add in two numbers. It's just that one of them is unknown, and we could balance the equation in order to find the unknown number, right? So we saw many different examples of this, like this one here as well. And we're going to be just doing some more of this today. So today is just going to be an easy class. We're going to track back a little bit today. We're not going to move forward really. Well, yeah, we are, I guess, but we were taking a look at how operations behave, and they behave the same way. Addition is still commutative. Subtraction is not commutative. You can see here that, you know, if we have x and x, well, we treat them like if they are the same number. So it'll be 2x. You know? So once we have the same number, x and x, we could add them or we could subtract them accordingly, right? Like this. But if we have something like x and y, those are two different numbers. So we can't really do anything here because we don't know what either one of them are, but we can change the order because addition is commutative. So all of these little tiny little things is where we get messed up, especially things like this. Yeah, not recognizing these things. We did a couple of small little questions that were easy, and then we spoke about multiplication. And remember, the entire point was to see that everything we did in number theory is the same thing in algebra here, right? An important point is 2x actually means 2 multiplied by x. And so when we have multiplication, we can actually write it like one number. So x multiplied by y could be written like one number, xy. And that, when you see xy, you're supposed to know that means x multiplied by y. Similarly, if you see x over y, you're supposed to know that means that x is being divided by y. And so fractions start to come into play. This is a super important one. A half times x is the same as a half x, which is the same as x over 2, right? All of these little things, right, is what people have problems with. And then we started to talk about fractions, and it might have been a little more complicated, but at the end of the day, we saw that fractions is just the same kind of thing. We spoke about the distributive law as well, and we talked a little bit about subject to the formula. And we're going to speak about all of these things again today, really, yeah? So today is just kind of a review of everything. And we saw that, you know, how to balance an equation, how to get rid, you know, when you have an unknown, you want to make the unknown the subject of the formula. That means that you want to have the x by itself, the unknown by itself, right? And get rid of everything else. But we can't just get rid of everything. We had to treat it like a scale. What we do to one side, you have to do to the other side. And this is how we balance an equation in order to make x the subject of the formula in order to find the x, right? And we saw that that is pretty much what we had to do for homework, is that we had to actually cover these questions here, which I believe was slide number 9. I'm going to do some of these questions here, and then we're going to talk about transposition, and then I'm going to do some more of these questions here using transposition, right? And transposition is just another way to balance the equation, just like what we were doing in the last class. So at the end of the day, let's just get it started here. So we have number 1, which is 7x is equal to 21. And for those, oh, so we have the first one here, 7x is equal to 21. And we know that this is 7 multiplied by x. So we want to get rid of that 7 there. So we divide by 7 on both sides. So 7x divided by 7 is equal to 21 divided by 7. So the 7's cancel, so I get x is 3. Thanks. So I hope that everyone is okay with this. And I'm just going to do a few of them. I'll probably do the first 6. And if I have any that you guys want me to do specifically, just let me know. We have this one here, 3v plus 3 is equal to 33. Right? So at the end of the day, one of the things that we have to do is, a lot of people will want to carry across this tree first because we want to make v the subject of the formula. But that would be a really bad move, because in order to get rid of that tree, you have to divide both sides of the equation by 3. So then this 3v plus 3, all of this is going to be divided by 3. And that might cause us some problems. And I'm not saying that you can't do it. Yes, you absolutely can. And yes, you will get the right answer. But there is an easier way. The easier way is, if this is the unknown, the variable that you want to find, you start far away from it first. So first, we look at the number furthest away, the 3. We'll throw across the tree. So now we'll just have, well, not throw across, sorry, because we're not doing transposition yet, right? But we see that as a plus 3, and we want to get rid of that plus 3. So we'll minus 3 from both sides of the equation. So 3v plus 3 is equal to 33 minus 3. So we can see here these 3's are gone. So we'll just have 3v is equal to 33 minus 3 is 30. And now we can see it's just a multiply, so we divide by 3 to get 3v over 3 is equal to 30 over 3. And so these 3's are gone, and that gives us v is equal to 10. Okay, so getting back to it, so I'll just do a few more and then we'll talk about transposition, which is that whole flinging across kind of thing. So we'll see here, I'll do this. What are some hard ones? Let's try these two. These two look pretty tough. Alright, these 3. Ooh, actually, I'd like to do this one as well. So these 4. I'll do these 4. Alright, let's start with this one. We have minus 2b plus 9. That is equal to 1. So again, I'll probably want to start further away from the b, so I'll deal with the 9. If I want to get rid of a plus 9, I'll have to minus 9 from both sides. So I'll have minus 2b plus 9 is equal to 1 minus 9. Right? So on this side, the 9's are gone. So I'll just have minus 2b, or negative 2b is equal to 1 minus 9. So negative 2b is equal to negative 8. So now we could say, well, alright, I want to get rid of negative 2b. So the negative 2b is being multiplied here. So I could divide by negative 2. Yeah, the negative 2 is being multiplied by b. So now I'll have negative 2b divided by negative 2. And that is equal to negative 8 divided by negative 2. I could do anything I want as long as I do it to both sides of the equation. Right? So these negatives will cancel over here. And I'll have b is going to be equal to positive 4. Right. So I know it might seem boring. I'll just do a couple more and then we'll talk about transposition, right? Which makes life a little easier. So I have this one here with 4 and q again. So I'll try not to cuss too much. So we have 4q minus 30. Yes. Thank you. It happens. And that is equal to negative 22. So we can see here I want q. So I want to get rid of a negative 30. So in order to get rid of negative 30, I'm going to add 30, but I have to do it on both sides, right? So now I'll have this 4q minus 30 is equal to negative 22 plus 30. These 30s are gone, so I'll just have the 4 and the q over here, and on this side is negative 22 plus 30, which is the same as 30 minus 22, which I do believe is 8. Okay. So now we have the 4 to get rid of. So what we will do, we'll just divide by 4. And in divided by 4, I will have 4q divided by 4 is equal to 8 divided by 4. I have to do both sides of the equation, so q is equal to positive 2. And if anybody have any problems, so I'll just do these two over here. So this one, I have negative 3y minus 2 is equal to negative 8. So we can see here we want to find out what is y. So y, I want y. I don't want negative y. I want y, right? So I want to get rid of this negative 2 first. So I will add 2 to both sides of the equation. So add 2 to negative 3y minus 2 is equal to negative 8. These 2's are gone. So I will have negative 3y left here. And negative 8 plus 2 is negative 6. Now I want to get rid of negative 3. So I will, negative 3 is multiplied by y. So I will divide by negative 3 on both sides. So now I will have negative 3y divided by negative 3 is equal to negative 6 divided by negative 3. So the 3's cancel and these negatives will cancel. So I'll have y is equal to 2. And then this one might seem easy, but you'll be surprised how many students have a problem with this. Negative a is equal to minus 16. And what do I want? I want a. And you're supposed to be able to look at this and you are supposed to be able to recognize immediately if negative a is equal to negative 16, then a is going to be equal to 16. Positive a is positive 16, and that is what we want. We want a. But how? Right? A lot of students can't go from here to here, and this is something you need to know automatically. You need to know automatically, right? So how? Well, remember this negative a is really negative 1 multiplied by a is negative 16. So now this negative 1 is multiplied by a. I could divide both sides by negative 1. So I have negative 1a divided by negative 1 is equal to negative 16 divided by negative 1. These negatives are gone. Those negative ones are gone. And I'm left with a is equal to 16. So yes, you're seeing the steps here, but you are supposed to be able to go from here to here and understand why. That any negative number is really multiplied by negative 1. Okay. So, nice. So, anybody have any problems or any questions? No? Okay. So we're going to talk about transposition now, and then we'll come back to this very same question sheet and do some of these questions here using the transposition method. What is transposition? It is nothing different than what we have already been doing. We have been balancing the equation using one method. So let's just say we have this equation here. Negative 2, no, not negative 2, sorry. 2x plus 3 equals 11. We know, well, okay, I have to get rid of the plus 3 first, so I'll minus 3 from both sides to get, you know, that gone there. So I'll have 2x is equal to 11 minus 3, right? And now 2x is equal to 8. And now divide by 2 on both sides. So that's 2x divided by 2 is equal to 8 divided by 2. And x is equal to 4. Now, this is what we were learning to do all the time. And we were seeing here that what we were doing is balancing the scale. What we do to one side, we do to the other side. But now we're going to talk about the method of transposition, which is doing the same thing. So for example, we have 2x plus 3 is equal to 11. So what we say is, you know what? We want to get rid of this plus 3. So we're going to fling it across. And that's how we just literally say it, or at least in this class. Fling it across. So we're flinging it across. So now we don't have plus 3 anymore. It only have the 2x. We fling over the plus 3. But once you fling over the plus 3, once it go over the equal sign, it becomes negative 3 on the other side, right? So the equal sign means that it kind of becomes the opposite of what it was in order for the scales to be balanced, right? So we got rid of the plus 3 and it becomes minus 3. So now we have 2x is equal to 8. And now we can see that we want to get rid of the 2. So what are we going to do? We're going to fling over the 2. So when we fling over the 2 on this side is multiply by 2. But on this side it'll become divided by 2. Yeah? So when we fling over the 2, the multiply will become a divide. And now we will have 8 over 2, which is 4. So transposition, we're doing the same exact thing that we did here, right? But you notice that we kind of just learning how to do it faster, right? So we could skip this step altogether, you know, and just jump from here straight to here. We could skip this step altogether and jump from here straight to here using transposition. So it helps us to save time once we know the rules, right? And one more time, if we're looking at transposition, when you fling over the 3, it magically becomes negative 3. But is it magic? No, it's not magic. This is what's actually happening over here. When we fling over the 3 across the equal sign to get rid of it, it becomes negative 3 on this side. Why does it become negative 3? Because when we fling over the 3 and we got rid of it, we minused it from this side, and so we have to minus it from this side as well. This is what we are actually doing. So transposition is not anything that is different. It's not anything that is new. You're doing the same thing, balancing the equation, but you're just thinking about it slightly differently, right? So, Sarah, do you understand the concept of transposition, how I explained it there? Lovely. So transposition is how you know how to do it, right? Yeah. And a lot of a lot of students very much know how to do the transposition. They know how to fling across the 3 and fling across the 2, but the problem becomes why. Yeah, so I just wanted to make sure you guys understand why it is when you fling across the 3, it becomes -3. Why it is that when you fling across a 2, it becomes divide by 2. And I want you to notice something again. And this is a mistake that a lot of students make when they're doing transposition. Notice here, when we fling over this 2, it didn't become -2, it stayed positive. It stayed positive. Why? Why did it stay positive? Because remember, we dividing by a positive 2 on both sides. That is why. That is what we actually doing. Right? The reason why this 3 became negative is because we had to minus it from this side. So that is why. Yeah? So when it comes to addition and subtraction, and please remember this rule, when it comes to addition and subtraction, when you fling it across, the sign will change. But when it comes to multiplication and division, when you fling that across, the sign will not change. You don't have to change the sign. So Jordan, you okay with this whole concept of transposition, right?
Yes, I did it.
No problem. So I'm teaching something that everybody know already. So this class should be a very easy class for you all. Well, since all are real good with transposition, let me get these 6 questions here. Right? And Jordan, did you do all the homework?
Yes.
Wow, well Jordan, you will just have to relax then, you know, because everybody else only did like half. So I want you guys to do these 6, and I'll only give you all 5 minutes. So just 5 minutes alone, do these 6 questions, try using transposition. Alright, so let's see how some of these are going, right? The first one we have here is negative 8z is equal to negative 40. So we know we want to find z, so we had to fling across the negative 8. So is multiply by negative 8. So when we fling it across, it'll become divide by negative 8. Yeah, it was a negative here, it'll remain a negative here. The negatives cancel, z is equal to 5. Right, so we have negative u plus 10 is equal to 30. Now I know how some of you do it, and when you're flinging things across, you can fling different things, right? So many of you guys would have probably fling across the 10 to get negative u is equal to 30 minus 10. And now you'll have negative u is equal to 20. And now this is a negative 1, so I fling across the negative 1, u is equal to 20 divided by negative 1, which is negative 20, right? So you all would have probably do it like that. I would have do it differently though. I mean, sorry, I shouldn't erase that, right? I would have say negative u plus 10 is equal to 30. Remember, this is really the same as 10 minus u. So if I fling across the negative u instead, I'll have 10 on this side is equal to 30 plus u. And then I could fling the 30 across here. So now it'll be the 10 minus the 30, because the 30 will become negative now, is equal to u. And so now I get negative 20 is equal to u. Therefore, u is negative 20. So you can see here that the u was negative, and I just fling it across to make it positive. And you could do it like that too, right? So we have 5k is equal to negative 25. So k, I'll fling across the 5, so negative 25 divided by 5. K is equal to negative 5. X plus 2 is equal to 29. I'll fling across the plus 2, so 3x is equal to 29 minus 2. 3x is equal to 27. X is equal to 27 divided by 3. 8 3s are 27. Sometimes I just forget my timetables too, not just up there. You can ask Arisa, and am I horrible at remembering my timetables? 3v plus 8 is equal to 20. Throw across the 8, so now I'll have 3v is equal to 20 minus 8. So 3v is equal to what? 12. So v is equal to 12 divided by 3. 4. And then the final one, 3z plus 4 is equal to negative 2. So 3z is equal to negative 2 minus 4. I take the plus 4 and I throw it across. So 3z is equal to negative 6. Z is equal to negative 6 divided by 3, which is negative 2. Alright, so the thing is that the whole transposition and flinging across things, this become incredibly important when we have to find the subject of a formula. And finding the subject of a formula is something that you will have to do in almost every CSEC exam question. Right? So, for example, take this, and I hope you all write this example down. We cannot solve an equation with more than one unknown. So if we had 2x plus 3 equals 6, we could solve for x there because there's only one unknown. So we could solve for that, no problem. We could find what x is. But here, we have more than one unknown. We have x and we have y. So once we have more than one unknown, you cannot solve that equation. But what we can do is we could rearrange it. So let's just say we could make x the subject of the formula. Making x the subject of the formula means that I'll just want x on this side alone and I want to get rid of everything else. So I do the same kind of thing, the same flinging across thing. You'll see here that I start with my original equation. The first thing I want to do is get rid of 3y. So I'll throw across 3y and I'll just have 2x is equal to 6 minus 3y. And now I want to throw across the 2. And this is where it becomes important, because you remember you're dividing by 2 on both sides of the equation. So when the 2 reach across on this side, it'll be everything here is going to be divided by 2. And just remember, if you wanted to simplify this, these are two numerators over the same denominator. So this could be simplified to 6 over 2 minus 3 over 2y. Right? And then we'll get the simpler answer of 6 over 2 is 3 minus 3 on 2y. So yeah, we could simplify it to get it like this. Split up the fraction, right? But leaving it like this is definitely fine for now. So you could see that we're using transposition, and even though we cannot solve this equation, we're using transposition to make a subject of the formula. We have been doing this for a long time. Like when you had area is equal to length times height, alright, or length times breadth or width. Let's just say you have the area, you have the breadth, but you wanted to find the length. You make the length the subject to the formula. So what I would do is I would write length times breadth is equal to area. I would switch my formula around so that length is on this side. And now length is equal to A area divided by breadth. You can see I threw across the B. So subject to the formula is something that we have been doing for a while, since primary school, right? And now we just kind of gonna take it to the next level. So if you check here, I have many subject of the formula questions, and so I'd like you guys to try out a couple of them. How much are there here? 1, 2, 3, 4, 5. I thought it was 6. Okay, and Soraya missing. Okay. Alright, so let me give all you 5, 1 each, right? So you can see here that let's do these 4. Alright, let's do these 5 here. Wait. Let's do these 5 here. And this here is circumference is equal to 2 pi r. So this sign is pi. And I know we didn't do pi yet, so you might wonder what pi is, but you know, it's not important right now. We will get to that. So 5 minutes to see if you could do that, and I'll ask you guys, I'll ask one of you all to answer one of these, right? So I'll give you all 5 minutes. Which is the first one? C is equal to 2 pi r, that one. And you have to make r the subject to the formula. So what would you do first? Right, so what I would do first, and that's right, what I would do first is flip the equation, because I know I want r on this side to equal to something. So just to make life comfortable, I would flip the equation. So I would put the 2 pi r on this side is equal to c on this side. And it's important to note that I actually didn't change anything. Yeah, I actually didn't change anything. All I did was flip it over, change the sides, but nothing in the equation has changed. What will I do now, Ursa? Choose one, choose one. We'll talk through it together.
S.
Ooh. H. Okay, oh, H. I was looking for number S, right? So we have, and this one is kind of very weirdly written, right? So I understand if you get that one wrong, but that's really n over 2 being multiplied by that. So if I write it over on this side, s is equal, and I could write it like this: n over 2 open brackets a plus l close brackets. Right. So you want to make L the subject to the formula. No, wait. L? No, you want to make A. So you want to get A is equal to something at the end. Right? So first I'll flip the equation. So n over 2 open brackets a plus l close brackets is equal to s. So Jordan, what do you think we should fling across first? Right. We can't fling across the L, but that's a real good answer. And I know why you say L, because I did say that, try to choose something that furthest away from the A. And so L seems like a proper choice, but the problem is, right, that L is inside of a bracket with A, and n over 2 is being multiplied by both of them. And so that n over 2 causing a problem because it's being multiplied by the L right now. You understand?
Yes, sir.
Right? So how about if we get rid of the n over 2 first? Because if the n over 2 wasn't there, then we wouldn't need the brackets anymore, right? So the n over 2 is a nice thing to fling across. And it have a couple of ways we could think about this, right? And this is a tough one, right? So I'm glad you chose this one. Remember n over 2. This is two fractions. This a plus L, because it's in brackets, you could treat it like one number because it's in brackets, right? The n over 2 being multiplied by the brackets, right? So really and truly, n over 2 is being multiplied by a plus L over 1, right? It's two fractions we could think about it as, right? So therefore you multiply your numerators and your denominators. So n over 2 into a plus L is the same as n multiplied by a plus L all over 2. Now this is exactly the same thing we were talking about the other day when we had a half multiplied by x is the same as x over 2. Yeah, x multiplied by 1 over 2. Right? So it actually is, so you see where this comes up, right? This comes up here. So you could recognize that this is actually n into a plus L over 2 is equal to s. So it have two different ways to do this, right? And what I could do is I could throw the 2 across first. Is divided by 2 on this side. This side is all of this being divided by 2. So if I throw the 2 across, n into a plus L is equal to s multiplied by 2. So Jordan, you following me so far? So far. And it makes a little more sense to you now, right? Right? Now, you see how I went from here to here? I did not have to do that, so I'll do it a different way. Just now, I'll do it a different way, right? So, now you could see here, all I have is the n on the outside, so I could throw the n across now, and if I throw the n across, I wouldn't need the brackets anymore. So when I throw the n across, it's multiplied by n on this side, so it will become divided by n on this side. And now I could throw, because the L I had no brackets no more, nobody ever bothering the L no more. The L all by himself. So now I could throw the L across to get A is equal to 2s over n minus L. Let me just write that a little better at the bottom there. So I'll get A is equal to the 2s over n minus L. Now, when I did this question, I went from here to here because I recognized that these are two fractions being multiplied, and so I could just put everything over 2. But what if I didn't recognize that? Is there some other way I could do it? Well, yeah. So let's try another way. If I had n over 2 into a plus L equals s, I could recognize that, hey, this n over 2 is being multiplied here. So let me fling across the n over 2. So I'll just have a plus l alone here. And I'm flinging across the n over 2. So I'll have s. And the n over 2 is being multiplied on this side. So when I fling it across, it'll become divided by n on 2. And I know that when I divide by a fraction, I am supposed to invert and multiply, right? This is arithmetic we're talking about here. So I'll have the a plus l on this side is equal to s invert and multiply. So s multiplied by 2 over n. And we can see here s multiplied by 2 over n, s over 1. So we will get 2s all over n. So now we end up with the same thing. A plus l is equal to 2s all over n. So a will be equal to 2s over n minus l. So you can see that things do get a bit complicated, but all that we did was we used those same rules that we had learned in number theory. We didn't use anything different. All of the rules that we used were the same rules from basic arithmetic, basic computation. When it comes to making it one fraction over here, and then throwing across the 2, and then throwing across the n. Or flinging across the entire n over 2 on this side here. There's two different ways we could do it to get the same answer. I hope you guys wrote that down. I am going to delete it. It's gone. Right. So Jordan, you're okay with that, right? Alright, so Jordan and Arisa. Cyan, are you there? Choose your destiny, Cyan. Yeah, same way, but I can make it out. K. Good choice. Y is equal to mx plus c. This is a formula. This is called the general equation of a line, and we will have to learn about this formula very, very soon. So y is equal to mx plus c. What should I do first? I want to make x the subject of the formula. I want to have x is equal to all kind of thing. So what should I do first? Alright, very good. So I'll flip the equation. So I'll put the mx plus c on this side is equal to y on this side. Nothing has changed. Now what? Very good. So it's I have positive c here. It's not in brackets. Nobody I'm multiplying by it or anything. So he just by himself. So I can just fling him across first. So now I'll just have mx alone here is equal to y minus c. And now what? Right. Very good. So it's multiplied by m on this side. So when I carry across the m, remember dividing both sides of the equation by m. So it'll be everything here. Y minus c, everything here is going to be divided by m. And this is the subject of the formula for x. So we solved for x there without actually solving for it. Very good, Cyan. Sarah, are you there yet? Sarah, I feel you ducking me in. Sarah, you're ducking me. I feel Sarah ducking. Okay. So Caitlin, give me one. L. Okay, nice. So Caitlin, moving a little brave here. So I have D is equal to b squared minus 4ac, right? And I want to make c the subject of the formula. So what should I do first? Right, so I'll rewrite it. So I'll put b squared minus 4ac on this side is equal to d on this side. So what now? Just now, wait as you want to make. You want to make c the subject to the formula, right?
Yeah.
Right, so you want to make c the subject to the formula. So c is the one that we want to leave here. So where you're carrying across the b squared,
Yeah.
right? And so when you carry across the b squared, what will it become?
The square root of
No, it will not. It will not become the square root. No, not at all. The only time it'll become the square root is if you was leaving the b here and you was throwing across the square. And we can see that just now. So if I had b squared is equal to d, I could throw across the square. If I left the b here and I threw across the square, and we spoke about this a couple of times, I throw across the square, it'll become the square root of d. That is what you're trying to do. That is if I'm leaving the b here, right? But you're not leaving the b here. You're throwing across the whole b. So this whole b squared, this is positive b squared, gonna get flung across. So I'm gonna be left with minus 4ac here, and that'll be d minus b squared. You understand that, Caitlin?
Yeah.
Yeah? So that is okay. I'm happy that you made that mistake. And you made that mistake because you were thinking too much. Yeah? So at the end of the day now, I recognize that minus 4ac, well, this whole thing is a multiply. So I could treat negative 4a like one number being multiplied by c. So therefore c is d minus b squared, this whole thing going to be divided by negative 4e. And that is your answer. Sarah, wake up yet? No. Sarah, you don't have to frighten me, you know. It's okay if you get it wrong and make mistakes. It's fine. No problem. Nobody get you know. So that's true, because when Arisa did hers, she made a mistake. When Jordan did hers, she made a mistake. Well, Cyan was smart enough to choose the easiest one, right? And Cyan did pretty well. And then Caitlin also made a mistake. And each one of you guys made some very important and very valuable mistakes, right? So I'm really happy for those mistakes, right? Because we learned a lot from those mistakes. Let's do this one here, right? It's supposed to be Sarah. P is equal to 2 into L plus B. And I want to make L the subject to the formula. So P is equal to 2 into L plus B. And I want to make L the subject to the formula. So I'll rewrite it. 2 into L plus B is equal to P. And I want L to remain on this side. I can't just throw across the B because it's inside of brackets with L. And it's being multiplied by 2. So I should get rid of the 2 first. So now L plus B is equal to P divided by 2. And now I could throw across the plus B to get L is equal to P divided by 2 minus B. Nice. So I have 2 questions that I want to give you guys as a test, just to see, and I'm pretty sure that none of you all will get it right. But it's the same one, and I think that Caitlin might get it right, right? But let's take the same one. D is equal to b squared minus 4ac, right? 1. And I want to make b the subject to the formula this time. B has to be the subject of the formula, right? And the next one t is equal to 2 pi times the square root of L divided by G in brackets. Alright? Look at that one. God. Good. Alright? The square root of L divided by G. Right? And I want to make G the subject of the formula. Oh God! How much time will I want for this? It's 4:07. I'll give Alia 4 minutes, 2 each. 2 minutes each. We'll do the first one. And what I will do is I will rewrite the equation b squared minus 4ac is equal to d. And remember, this time I want to make b the subject of the formula. Okay. So since this could all be treated like one number, I could just fling across that entire thing. So now I will have b squared is equal to d plus 4ac. Yeah. Now I want b to be the subject of the formula, and so therefore I have to get rid of the square. How do you get rid of a square? Remember, if 5 squared, and this is the hint, if 5 squared is equal to 25, then to get rid of the square, 5 is going to be the square root of 25. Right? So when you fling across a square, you just get a square root. We did talk about this. We spoke about this when we spoke about powers and squares and square roots. We talked about this. Yeah. So I hope that you guys remember. If you don't remember, that's fine. That's fine. So you can see here that when we throw across the square, everything on the other side of the equation becomes under the square root sign. Right? So the thing is that b squared is equal to all of that. So therefore b is going to be equal to the square root of all of that. And that's it. 3 lines. Right? So cyan, still confusing? Pretty easy, right? How about you, Jordan? Of course it's not confusing when I do it, right? but you understand what I did there, right?
Yeah.
Alright, lovely. So let's try this one. And the first thing I'll do, of course, is I'll flip the equation. So I'll put the 2 pi into the square root of L on G in brackets. So the square root of all of that, everything inside of the brackets, is equal to t. Right? So, I mean, oh gosh, I can't really touch the square root and all of the things in the brackets because they're all being multiplied by 2 pi. So let me fling across the 2 pi first. So I'll have the square root of L over G, and it's multiplied by 2 pi on this side. So on this side it will be t divided by 2 pi. And just as what we saw here just now, when I had 5 squared is equal to 25, and so therefore 5 is equal to the square root of 25, we could talk about that in the reverse order. Because if I have the square root of 25 is equal to 5, if I want to fling across a square root sign, the other side of the equation will become squared. And of course, this is not only true, if you remember the class when we spoke about it, is not only true with square root alone. If it was a cube root, then this side would have become cube. If it was a 5 root, then this side would be to the power of 5. Yeah? So when you're throwing across any power, you know, it'll become the root of that power. The root of that power. So I can't touch that L over G unless I get rid of that square root sign. So if I fling across the square root sign, guess what? L over G gonna be on this side, no brackets no more, is equal to T on 2 pi, and all of it is going to be squared. And when I fling across the square root sign, whatever it is on this side of the equation is going to become squared. Now, this is where things get real interesting, because I want to make G the subject of the formula, right? So this is another very, very important thing. If I want to fling across the L, how am I going to fling across the L? Right? Well, you have to remember L on G is the same as L on 1 multiplied by 1 on G. So the L is really being multiplied. So I could throw it across and I could get it to be a divide by L, right? But it have an easier way to do it. And the easier way is this. Don't throw across the L, throw across the G. If you throw across the G, you'll be left with L is equal to T over 2 pi squared multiplied by G. And so now we have the G over here. The G was in the denominator, but it's not in the denominator anymore. So now we could take this entire thing that is being multiplied by G and fling that across. Fling that back over there. So now I'll have L being divided by all of this, because all of this was multiplying G. So all of this is going to now become divide. So divide by T over 2 pi all squared. And that is equal to G. So therefore, G is equal to L all over T over 2 pi in brackets all squared. How do you feel about that? Jordan, how do you feel about that? I hope so. Arisa, how do you feel about that? And that's why I gave you guys these. And trust me, you'll never get a question like this in CSEC. Eh? You wouldn't get a question like this in CSEC at all. You'll mostly get more things like in CSEC, you'll get a question like this. Y is equal to mx plus c, make x the subject of the formula. Right? But I just want to make sure that you guys, because it's not unheard of for you to get something difficult in CSEC. And you see this, even though it is difficult, right? It is still part of the CSEC curriculum. You are supposed to be able to do this as part of the CSEC curriculum. Now, it have one thing that I wanted to do with you guys, and that is an alternate way, right? Now, if we check something here, I'll put this there, and I'll put this there. When we were over here, we wanted to make G the subject of the formula, right? Just now, right? Making some space on the page. we wanted to make G the subject to the formula. And what we decided to do was to, instead of keeping G there, because G is in the denominator, that's a problem. So we decided to fling across the G. And the G come on this side. Multiply by all of that madness. Okay? And so that kind of solved the problem. But what if we didn't fling across the G? What if we fling across the L? What would have happened? Well, I have L on G is equal to all of this. It doesn't matter, it's all in brackets. So even though it looks complex, you're just treating it like a one number because it's all in brackets, it's all squared. So you can treat that like a x squared if you want. Now if I fling across the L, we saw that this is really L over 1 multiplied by 1 over G. We saw that to give you L on G. So if we fling across the L, we're going to be left with 1 on G. Right? So if I fling across the L is multiplied. So if I fling across the L, I'll just be left with 1 on G here is equal to T on 2 pi all squared divided by L, because the L was multiplied on this side. So when I fling it across, it's going to become divide. And this is another cool rule that you could learn. Rule. Right? It's not really a rule, but if I had 1 over x is equal to p, right? And I wanted to make x the subject of the formula, I could just simply flip both sides of the equation. So if I flip this 1 over x and it becomes x over 1, then I could flip this p over 1 and it'll become 1 over p. So therefore x is equal to 1 over p. This is a nice little rule to keep. Right? And why does this work? That you could flip one side a fraction and you could flip the other side. Well, I mean, we could check it, right? Check this, right? 1 over 2, a half, is equal, and I hope you guys writing this down because this is good stuff. A half is what? A half is 4, no, not 4 divided by 2. A half is 2 divided by 4, right? 2 divided by 4. So this is a correct statement that 1/2 is equal to 2 divided by 4. So let's flip this side. Flip this fraction to give me 2 over 1 is equal to, and I could flip this fraction to get 4 over 2, and this is also correct. Yeah, 4 divided by 2 is 2, right? So we could see how that works there. Now another reason why it works is because if I had 1 over x is equal to p, I could say, well, this is divided by x. So I could fling across the x and I could say that 1 is equal to p multiplied by x. And then I could fling across the p to say, well, x alone on this side is equal to 1 divided by p. And look at get back the answer. So we have this nice little rule here that you could actually flip fractions on both sides of the equation. And we saw how it works with real numbers here. And we saw why it works, what you're actually doing to the equation. You're actually carrying across the x and bringing back across the p. That is what you're actually doing. So in this case here, I have 1 over g is equal to a fraction. So if I want, I could just flip it and say, well, g is equal, and flip this fraction here, L all over t divided by 2 pi all squared. And look, I end up getting the same thing. I know it's a lot. I know it's a lot, right? So we do have some subject of the formula questions here, and we have a lot more subject of the formula questions later on, so you guys will have to do all of that for homework, right? Now before we go, I'm gonna let you all go just now. We just have one more thing to do again, and I know all your brain might be totally mashed up, but this thing is an easy thing, so don't worry. We have one more easy thing to do, right? Jordan, your brain mash up? Cyan, your brain mash up? A little bit. All you know, all you tired. All you wish we could have over now. Don't worry. 5 minutes, 10 minutes again, and we gone, right? So we have some subject to the formula questions here. You'll have to do all of them. And we also have some subject to the formula questions here. All of these questions, you have to make T the subject of the formula. So wherever T is, you have to make T the subject of the formula. These are some really nice questions here. They're fun. You all never play Sudoku? No, nobody ever plays Sudoku?
Yes.
Right. Well, this is, to me, maths, this algebra stuff is kind of like Sudoku. It's a puzzle. It's real fun to try to figure out, especially the subject of the formula stuff. Right? You could treat it like a puzzle. You know, don't treat it like homework. Treat it like, you know, you want to do a puzzle. Right? So if you're sitting down on the bus or you have a long drive, carry a maths book and do some puzzles, right? So now we're actually going to talk about worded problems. And this is slightly easier. You wouldn't particularly get any hard worded problems. We'll talk about these, and then we have some worded problems here that we will actually try to do. Right? Okay, yeah. We don't have to do that one today. We could just do the worded problems and end with that, right? So I have some equations here with some unknowns. This equation has one unknown. This equation has one unknown. And this equation has two unknowns. When you have an unknown, it's not just in maths where it is meet unknowns. It is meet unknowns in many aspects of life. In everything in life, you don't know everything. It have things that are unknown. And so you have to be able to take situations in life and turn it into maths and turn it into algebra and be able to work it out. So I have algebra and maths here, and I want to see if we could actually turn it into life. We're working the other way around. So I want to take this, and I'm going to take this, and I am going to write a worded question, or I am going to write this in terms of a worded problem, right? And I want you guys to do it with these two. And I want to hear some of your worded problems. So let's see this one, right? What could I do? I have right. So we could have, I had $6 in my pocket. I bought a pencil and got $2 change. How much did the pencil cost? Simple little thing. And you can see that it is, is a kind of question that, you could meet in your life. How much something costs. You could actually work out an equation. So you can see here that the cost of the pencil plus the amount of change that I got is equal to the total amount of money I had in my pocket. So I had $6 in my pocket. I bought a pencil. I don't know how much the pencil cost, but when I buy the pencil, I got $2 change. Okay. So how much did the pencil cost? And obviously everybody know the pencil costs $4. That's an expensive. Actually, a pencil more expensive these days, yes? But I took this and I turned it into a worded problem. So do you guys think that you could turn these two into worded problems? It doesn't have to be anything with money. It doesn't have to be anything with a pencil or anything like that. So take 2 minutes, see if you could turn these into some worded problems. Remember, the thing that is unknown is the thing that you probably want to find. Yeah, that is the thing that you'll want to find. You want to find the thing that is unknown, right? So, let me see how good Ali is. A little more brain busting stuff. I'll give Ali our next 2 minutes. And then I want to hear some questions, right? Let's see. Let me hear what he was thinking.
It is 2 times I was trying to figure out 2 times.
Well, yeah, no, that's no problem. That's fine. So she did was what she did was 2 times a certain number. And you notice they say a certain number, so we don't know what number is. That is what is unknown. 2 times a certain number plus 3 gives 11. What is that number? Fine. That is actually pretty good. No problem there. What about this one? And of course, remember, this have 2 unknowns there, so you can't really solve it. It's not something that we could solve, but can we put it in words? What if I said 2 apples and 3 oranges cost a total of $6? Does this describe that equation? Jordan, Cyan, how do you feel about this stuff? How do you guys feel about this stuff? So did you have any versions of word problems that you wrote? No, you didn't get through with anything? So the whole point is that you're looking for the number that is unknown, and that is what you will treat as X. So let's look at some actual worded problems now. Right? You bought a magazine for $5 and 4 erasers. You spent a total of $25. Total. That word is important. How much did each eraser cost? Each eraser. Right? So I bought 4 erasers. I want to know how much each eraser cost. So let's say an eraser is X. Right? Because that's the unknown. I bought 4 erasers, so 4x. And what else did I buy? I bought a magazine for $5. And they tell me how much the magazine cost. So 4 erasers and the magazine for $5, right, cost a total of $25. And from here, I could find how much and eraser cost. Jordan, how you feel about this? Do you think you could tackle some of these worded problems? You think so? What about you, Cyan? Alright, well, we will see. So let me give you all one. This one you should be able to do. Just, you know how to solve it, eh? Just give me the equation. Just give me the equation. And this one, I am pretty sure you will not be able to do. Arisa, or at least Caitlin, is supposed to be able to do this one, right? So, as I say, you don't have to solve it, right? You do not have to solve it. You just have to give me the equation. Number 2, everybody should be able to do number 2. And number 3, nobody might be able to do number 3, but number 3 is super important. Yeah? So, Aliyah had $24 to spend on 7 pencils. After buying them, she had $10 left. How much did each pencil cost? And of course, you don't have to actually solve how much each pencil costs. I just want the equation. So the cost of a pencil would be X, because that is what I want to find. So could anybody give me the equation for number 2? Absolutely correct, yes. 7x plus 10 equals 24. Let's see how she got that, right? So I want to find how much each pencil cost. So I know that the cost of a pencil is X. How many pencils? 7 pencils. So we have 7 times X, 7 pencils, right? So Aliyah had $24 total, and she spent on 7 pencils. After buying them, she had $10 remaining, right? So at the end of the day, the cost of the 7 pencils plus the $10 she had remaining would have made up the $24 that she had. Yes? So, good. Caitlin, give me number 3. Caitlin, you do this already. Uh-huh.
I know these items like one after the other. So
Yes.
X plus and then brackets X plus 2.
Close.
Next one is plus brackets X plus 3.
Right. No, but you're real close. You're super close, right? So imagine the sum of 3 consecutive numbers. What are 3 consecutive numbers? Well, it's 3 numbers that come one after the other. So, like, I could have 2, 3, and 4. These are 3 consecutive numbers. 3 just come after 2, and 4 just come after 3, you know? Or I could have 10, 11, and 12. These are 3 consecutive numbers. So what they're saying is that I have 3 consecutive numbers, and the sum, which means addition, if I add up the 3 consecutive numbers, I'm supposed to get 72. So how do I find what those 3 consecutive numbers are? I don't know what they are. Well, if we look at how consecutive numbers work, if the first one is 2, then the second one will be the 2 plus 1. And then this one will be the same 2 plus 2. Yeah? So I have 2, 2, and 2. Right? Whatever this first number. Let's just take these consecutive numbers. 10, 11, 12. Right? The first one is 10. The second one is 10 plus 1. And the third one is 10 plus 2. These are how consecutive numbers behave. So I do not know what the consecutive numbers are though. I do not know. So I'll call the first one x. And if the first one is x, then the second one going to be x plus 1. And the third one is going to be x plus 2. And that will give me 72. And now you could actually try to solve. It have nothing multiplied here, so I could remove the brackets x plus 1 plus x plus 2 equals 72. So 1, 2, 3, that's 3x plus 3, 2 and 1 is 3, is equal to 72. Oops. So therefore 3x is equal to 72 minus 3. 3x is, what's 72 minus 3? 69. Yeah, I believe it's 69, 70, 71, 72. Yes. So x will be 69 divided by 3. I will use 69 divided by 3 is 23. So we can see here that we found the first number. The first number is 23. So therefore the second number will be 24 and the third number will be 25. And if we add 23 plus 24 plus 25, we get 72. So this is a really nice one. And as I say, I didn't expect anybody to get it right. Caitlin, you were close. This here was supposed to be x plus 1 and this here is supposed to be x plus 2. But you can see that I didn't use any great special knowledge to figure this out. All I did was I used the word consecutive and I asked myself, what does the word consecutive mean? And it means one after the other. So that is a really lovely question, right? And there is another one like it right here. Number 4 is another one that's very similar to it. So I hope that you guys have fun with that. Nice. So that is it for today. So today we spoke about transposition. We spoke about some of these very simple balancing the equation. And trust me, in CSEC, you'll probably get an equation that looks like these guys here. Right? So if you could do these, you're in good shape. And then we spoke about the concept of transposition, which helps us to save time. Instead of all of the balancing of the equation, we could just transpose things. And we saw that transposition here, we could use it when we have an equation that we want to make something the subject of the formula. And of course, we tackled some subject of the formula questions. I have to admit, because I was asking throughout the class, all you understand? Yes, I understand. You're cool? Yes, I'm cool. But then when you did the subject of the formula questions, you guys made some really simple mistakes. Simple but very valuable mistakes. One of the simple ones was Arisa with the 2 pi and throwing it across and it becomes minus 2 pi. Be careful. Think about what you're doing. Look at what you have. You have 2 pi being multiplied by r. Look at what you have. Right? You guys are coming to a math class now. So now you have ammunition. Right? So what some of you guys just do is you will look at a question, and before you even start to think about the actual question, you will start to try to guess things. You look at the question looking hard, so you'll automatically assume it's hard, and you'll try to guess what to do instead of The first mistake you just make, everybody here, the first mistake you all just make is assuming that the question is hard. That's the first mistake you just make. Because if you saw what we did in today's class, none of the questions were hard. None of them. Right? It's just that you guys assumed that they were hard. But none of them were actually hard. You just had to look at what you have. Look at what being multiplied. Look at what being divided. Look at what being added and subtracted. And then that'll give you a better idea. So, this is the last class for the summer. I will not see you guys until September, the first week in September, right? I don't know if it'll be a Saturday or it'll be a Tuesday. I had to check my calendar, but I will post it in the WhatsApp group when we're ready to start back, right? You guys will have an entire month, and I'm not just going to leave you all with nothing to do. No, you are going to have homework that is going to be due for me. And let me show you what the homework is. Caitlin, you see in this Google Classroom here? All right. So the homework is in classwork. We're going down to algebra, intro to algebra, and we still in this intro to algebra here. This here, click that here. And we have many different things. This was the last class. This class, today's class, I'm now recording it. So I will upload it over here maybe by later tonight. Today, this class should be uploaded right here. Your homework, you have 2 question sheets here. The first one is our Google Slides. This is the Google Slides that we were working with, right? Some of the stuff from the last class that we were talking about, and then this is from here, is from this class. So you see from here, right, slide 9, and please write down this homework. Slide number 9, which you did mostly, but none of you all did all of them. So try to do the ones you did not do. Then we have slide 12, slide 13, and slide 15. So 9, 12, 13, and 15. So you have these questions to do. And there is also this PDF here. Let me see if you are able to do this PDF. Solve for each of the variables. Yes, or they could do this. Oh, this one have answers. Yay, so this one actually have answers. Yes. Yes, I want you guys to do this one as well because it have answers. And it have some subject to the formula here as well. Right? Subject to the formula. And it's not long. It's just it have answers, so it's looking long. Right? So all of these questions, our first class in September, we are going to spend the first class doing all of these questions here. So in this one, we have slide 9. Is it 9? Let me just make sure. 9, 12, 13, and 15. Right? And in this one here, we have the PDF, where you have to do the entire PDF, and it does have answers for most of them there. Right. So I am leaving you with a good amount of work to do, but you guys have a whole month, and honestly, you all are supposed to be able to finish all of those questions in maybe one hour, maybe 2 hours. You're supposed to be able to complete all of those questions in 2 hours, right? So you all have 2 hours of questions to do, and you have a month to do it in. So I expect no excuses, please. Now, before I go, I just want to say this, especially for the adult students, especially for the students who might be repeating, you guys, especially for my adults who have not been here in a while, you guys know the amount of work that we have in front of us. We have a lot of work in front of us, real plenty. I don't want to frighten you, but I mean real work, right? And it's going to be brain busting work too. But all of the work will require algebra. It'll require being able to balance an equation, and it'll require being able to change the subject of the formula. So if you could do these things, then you will make the rest of the work easier. So please, in moving forward, you see these questions I give you here today, please do them. Please try to understand them. Please make the effort. Do not slack off with this. I know you all might seem like, well, all right, like Sarah and Jordan was saying, yeah, I do transposition, that's fine, you know, that thing. But then when we reach subject to the formula, guess what? It's nothing different, you know. It's just that it don't have numbers anymore. Yeah, but it's still nothing different. So please, you see, this part of the curriculum is the most important part. If you could get this part correct, if you could get this part right, if you could understand this first month, July, the month of July, everything we did this month, if you could truly understand everything we did this month, then the rest of the curriculum is going to be super easy for you. But if you have problems with stuff that we did in July, then you're going to real catch your tail for the rest of the curriculum, because it's a lot of work we have to do still, right? So I don't mean to frighten you, but please spend your time wisely, because the time gonna go like that, right? And what I would suggest, because I'm also a music teacher, right? And I am suggesting to you a music technique that works. What I suggest to you is this. Please listen to my advice. Do not sit down to do all of the questions one time. Do not do that. No. What I suggest is that you spend 10 minutes every other day. Do a little bit today, do a little bit the day after, not even the day after that. Every other day, not even every day, 10 minutes. That's all. 10 minutes every other day. I just tell my music students this, who practicing guitar, practicing piano. If you do 10 minutes every other day, what that will do is it will constantly and consistently remind your brain what to do. So you'll be constantly reminding your brain in just these little 10-minute segments. You will constantly be reminding your brain over a long period of time what to do. So by the time September hit and we start back class, your brain is not going to forget. You would have really known everything. But if you make the mistake of trying to knock off all of the questions in one night, then guess what? You might get all of them right, sure. But you're doing it once, and then you ain't doing it again. So by the time September hit, your brain is going to forget. And you're going to forget all of those little things, like throwing over the square root, or squaring both sides, or flipping the fraction. All of those little things you are going to forget, right? So I am telling you this is a proven method, right? Do not do all the questions in one shot. 10 minutes every other day. will make you a much stronger math student, because it's about training your brain consistently over time. And that is what we're here to do.